This is going to be the last recording for chapter 25, slide set A. And I went back to, this is slide 68, because I want to review how filtration rate is regulated. So kidney filtration rate, or what we call GFR, glomerular filtration rate. One way that it's regulated is called autoregulation, and there are two types of autoregulation. The myogenic mechanism, remember, is just high blood pressure causes increased stretch in the blood vessels, and that leads to them constricting. It's kind of like they fight back by constricting and getting even smaller, and then that will decrease the blood pressure. So that's called the myogenic mechanism. And the tubuloglomerular mechanism has to do with sodium chloride concentration, salt concentration, and that is detected by the macula densa cells. So as filtrate rate increases, there will be high levels of salt, sodium chloride, in the filtrate. And then that will cause the afferent arteriole to constrict. So high filtration rate increases salt in the filtrate, which is detected by the macula densa cells, and then that leads to the constriction of the afferent arteriole. Then we have neural and hormonal mechanisms that regulate GFR. All right, first we have the sympathetic nervous system, and under abnormal conditions, such as extremely low extracellular fluid volume, which corresponds with low blood pressure, the sympathetic nervous system releases norepinephrine, and then the adrenal medulla releases epinephrine. That's going to cause systemic vasoconstriction, and that will increase blood pressure all over the body, which of course increases blood pressure to the kidneys. That leads to constriction of the afferent arterioles, which will decrease filtration rate, and it will lead to increasing blood volume and blood pressure, because when you increase blood volume, that will increase blood pressure. Okay. Then we have the renin-angiotensin-aldosterone mechanism. This is the main mechanism for increasing blood pressure, We've mostly been talking about high blood pressure and how to decrease it. But what if the blood pressure is low? So there are three pathways that lead to the release of renin by the granular cells in the kidney. Number one is the direct stimulation of the granular cells by the sympathetic nervous system. Number two is stimulation by activated macula densa cells when filtrate salt concentration is low. And number three is reduced stretch of granular cells. So all of these happen with, the number 2 and 3 happen with the myogenic mechanism. So it's kind of like the autoregulation is interacting with other regulatory mechanisms. All right, and you can read through this on your own if you want to, but it just goes through all of the different pathways that if blood pressure is low, what happens in the body to raise it. Okay, so you start out with low blood pressure, that's going to decrease the filtration rate. And what are all the things that happen to raise the blood pressure? And what we're looking at, this over on the left shows you the myogenic mechanism, which has to do with the stretch in the afferent arterioles, and it has to do with and then the tubuloglomerular mechanism has to do with the macula densa cells. So those two we kind of talked about already, but let's look at, and I'm going to blow this up, let's look at the renin-angiotensin-aldosterone mechanism for raising blood pressure when it's too low. So the granular cells of the juxtaglomerular complex of the kidney, we saw those earlier, they release, in response to low blood pressure, they release renin. And then that leads to the formation of angiotensin II, the formation of angiotensin II. So that's why it's called the renin angiotensin aldosterone mechanism, because low blood pressure causes those granular cells to release renin, and that leads to the conversion and the formation of angiotensin II. And really the word for that is the activation, angiotensin II, and then that leads to increased aldosterone secretion by the adrenal cortex. Increased aldosterone secretion by the adrenal cortex. Now, what aldosterone does is it increases sodium reabsorption by the kidney tubules. And there is one thing that we learn in anatomy and physiology is that water follows salt. So if the kidney tubules are reabsorbing more salt, more sodium into the blood, water's going to follow. And when you have more water in the blood, you have a higher blood volume, and higher blood volume raises blood pressure. The other thing angiotensin II does is it leads to vasoconstriction of systemic arterioles. And by constricting those arterioles, you're going to, and this is like systemic means all over the body. And so you're going to raise blood pressure that way. So that is the renin angiotensin aldosterone system, which is designed to raise the blood pressure when it's too low. All right, there's a clinical note here on a condition called anuria, which is abnormally low urinary output, less than 50 milliliters a day. Remember, we said that the average is 180 milliliters per day. So this may indicate that glomerular blood pressure is too low to cause filtration. It can lead to renal failure. So renal failure and anuria can also result from situations in which nephrons stop functioning. Examples are acute nephritis or inflammation of the nephrons, transfusion reactions, and crush injuries where the kidneys are crushed.